I'm going to bring on our first speaker, Haytham. He is the CTO of Union AI, and he's actually been a longtime supporter of the MLOps community. They came and they were one of our first sponsors in 2020, back when we first started. And we've been able to grow together, and up until this point, we actually grew so that now we're here in their hometown, your hometown, having this conference on AI agents. Things have morphed and changed a bit, but that's the fun of it. So please welcome to the stage, Haytham. There you go, sir.
Thank you, Dimitris. Is the mic working? I hope so. All right. Hi, everyone. My name is Haytham, and yeah, as Dimitris said, we are long time partners with MLOps. We love the community. We have essentially grown with the community, and we would love to support any way we can. I am one of the co-founders and CTO at Union, and co-founder, co-author of Flight, open source project. We have a booth out there. Come check it out. More on that at the end. But to kick things off, let me just give you a quick story. Many moons ago, about 18 years ago, actually, this past weekend, where I was getting married and we wanted to plan our honeymoon. And I called up a travel agent. That was maybe my first interaction with an agent. Over the course of many weeks after that, we had many email exchanges, phone calls, dropped phone calls. Never once did the agent ask me to, repeat everything I said or we communicated about over the past weeks. It was a great experience, but it also, I keep reflecting back on this whenever agents come up these days, because I want that. I want very long-running sessions. I want an agent that doesn't forget what I said or doesn't complain about the context getting too big and is able to recover from dropped phone calls and can call me back and continue right where we left off. Just a great experience with a human. On the other side, I would love to have that same experience with the agents we build these days. Maybe to get us started, I will ask really quickly, show of hands, who has experimented with building agents, maybe OpenClaw, you're curious about agents, and great, many of you. And keep your hands up if you have shipped that agent to production, if it's running. Yeah, I know, very few of you, thank you. And that's really the whole point. If you have built one, it's very time consuming to get the right context and the right prompts to get the LLMs to do what you want, and the guardrails around them, and the API calls, and the tools, this and that. And you do all of this probably on your laptop to get the thing doing the right thing, and then you try to throw it out to a production deployment, and whole set of new issues come up, right? The agents crash, you run out of memory, the tools are not scaling to the number of users you're trying to hit it with, you get API limits and throttling and just all kinds of production issues that you don't really see, and they're not really related to the quality of your responses you're getting from the LLMs or from what the agent is trying to do. And this is to be expected, right? Agents do fail, and they will fail in production. And I think instead of trying to really prevent that, or trying to design the perfect agent that will never fail when you put it in production, you should be building agents that tolerate that know how to react when failures happen, because they will happen. And we try to categorize the types of issues that you will see while building an agent. In the top here, you will see probably what you spend most of your time doing. They start the semantic and logical errors, trying to get the agent to do the thing you are designing it to do. Maybe it is the travel agent, or maybe trying to build some cool agent that develop or build apps for you. That thing is your IP, this is your idea, this is the thing you're innovating in, and rightfully so. You spend most of the time doing or iterating on that to get the right output that you want, and mostly, again, on your laptop. But then bunch of other issues happen, right? From infrastructure, network issues, the tools you think you can depend on start like barfing at you or just failing randomly or throttling you. You hit API limits, and they manifest as, well, maybe corrupt context. You have to restart sessions, and it's like a terrible experience for your users once things run in production. Yep. In building an agent, building a platform that can run agents, we think of them as like from sort of first principles. And we think there are three main things you should really consider or require from a platform that will run your agents. And they inform how you build the agents too, but how the platform run them and give you these guarantees from the get-go. The first of those is dynamic. You don't want, a constrained, you have to build the agent this way, and it has to be a DSL, and you have to tell me if you're trying to branch or you're trying to do a loop. That is very constraining, and I don't think leads to good agent development experience or really the dynamism you want from your agent. I think the platform you're building on should allow you to write the code the way you think about it. It should be intuitive. You should be able to build the agent to interact with the user the way you think it should interact, as natural as it gets, with no constraints about how you do so. The second is durability. When you're building an agent, the last thing you want from that agent is when a failure happens, and it will happen, that you have to restart or start all over again. It's bad for you, because you're wasting probably very precious tokens that have been wasted so far. But it's also bad for your customers, because they will get a terrible experience if, halfway through in a 2-hour session, they have to start all over because the agent crashed and you lost the machine, and you have to, reprompt and redo everything again. And then the last requirement is you want to be able to build defensible or defended agents. And what we mean by that is sometimes your agents will want to do wild stuff. Maybe it wants to write code because none of the tools you provided or gave it can do the thing it's trying to do right now. Where will you run that code? How do you run that code securely? Or maybe it gave up. You put guardrails around it. You're like, give it your best shot, try 5 times to build this tool, and iterate with the LLM to fix issues. But then what happens after the 5th time fails? What should happen? Probably prompt the user. Maybe ask the user, what should I do? Maybe it is just not a doable task, or maybe it needs more input from the user to proceed and try the next attempt or try the next experiment. And I will go through each one of these. We'll see how our take, hopefully not a hot take, we'll save those for later, on how should you think of building them, how natural that should be, and what should the platform just give you out of the box. The back behind me here is just, hopefully, what should resonate with everyone as normal Python code. You write functions, you write your code with loops and try catches, try except in Python, and you sort of execute it in a natural way. It's async. Yeah. The next, I'm highlighting a couple of pieces here where we think your code, one of the ways it can tolerate infrastructure failures, say you run on spot machines because they're cheaper, you get a cheaper GPU, or you're running on a Neo cloud, so you can get actual GPUs because you can't find them otherwise. Infrastructure failures happen. If your code is not aware of the infrastructure it's running on, it will not be able to react to failures there. So if it doesn't know that, oh, I allocated a 32 gigabyte RAM for this task, or for this job, or for this code execution, when that happens, when it fails, when you get an out-of-memory error, it will have no idea what to do with it, because it didn't even know that it was running on a 32 gigabyte machine in the first place. So we think one of the ways you work around that is that you declare the infrastructure that you need right in your code. So at the top here, you build this environment and you say, I need this much memory and this many CPUs, and you can iterate. It's all dynamic code. There is no DSL required. You're just running your code on that infrastructure. And the second piece we talked about durability and handling failures when they happen. What happens if this function fails, right? You can maybe put try-catch around it. Maybe you can catch most of the errors that happen in this function. But there will be errors that happen that you can't catch, that are external to you. Again, if the spot machine is taken away from you, it's not a thing you can handle in your function, right? Because the entire process will just go. If you run out of memory, it's not a thing you can handle. So you want to be able to tell the system that I want this job to be retried or to be rerun on maybe a different piece of hardware, or maybe just in the same hardware, try it again, because there's some uncertainty about the code it's running, and maybe a second attempt will succeed. So you want to be able to creatively say that. And then lastly, when you launch other pieces, right, when you're like, I want to run this external code, or I want to call this tool, or I want to do something outside of your process, you want to monitor that and know and react to failures that will happen in that piece of code. It, again, could be infrastructure failures on the other side. It could be bad allocation of resources, right? You assumed that running this piece of code doesn't require that much memory, so you launch it somewhere else, but while it's running, it runs out of memory. You need to know that, and if you know that, you can change the code, right? Because, again, the infrastructure is declared here. You can change the memory allocation and then retry the same code, right? Because now your code is controlling both the infrastructure, the compute, and the logic that's running on it. The second requirement about durability, talk a bit about this because I think it's very important. There are a few aspects when you think about durability. There is, I'm running a session, right? So there's one ongoing session with a user, and while this is happening, something bad happens in between, right? And you want to recover. You want to do crash recovery. And this is a very, I think, well understood problem in normal services. If you're running a service, services crash all the time. People even deploy what they call chaos monkeys in their infrastructure to like kill services intentionally and make sure the entire system continue to behave reliably. This will happen. The problem with agents is they're long running. Like you can have a session open with a user for weeks at end, right? So something bad is going to happen while this session is going. So how do you recover from this? We think the system should be able to tell you that. It should be able to record every action this agent has taken, and on, with your permission as the developer of the agent, you should be able to recover from those actions and not have to run them again. This is particularly important if some of these actions are not deterministic. So if I'm calling an LLM, 2 days ago, if I call it again today with the same prompt, it's probably not going to give you the same response. So caching that and making sure we don't do it again. So my code, my agent, as it's recovering from a crash, can behave deterministically. But also, if you prompt the user, if I ask a user for something at the beginning of the session, right, and the session crashes and recovers, you don't want to ask the user the same question again, right? That would be annoying. Imagine if my travel agent forgets and then 2 weeks later asks me, where were you gonna travel again? Or what's your budget again? That would have been annoying. Yeah. Next. And then the second piece for durability, once you zoom out of this one session, you have to account for having, in parallel multiple executions, right? There are multiple users using your system. They are, in a lot of cases, doing the same or similar things. So there may be calls within the agent that you want to cache because they don't change that often. If I'm doing a web search, probably on the same term, on the same day, it's probably okay to cache the response. But if I'm calling an LLM to generate a report, maybe I don't want to cache that. So having the ability and the power from the platform to decide that for certain things, I'm okay caching and getting like, share the cache across different agent runs is very powerful. Will save you, again, tokens, but will also make the agent run a lot faster for those subsequent runs. The I think last piece in durability is making failures cheap. Again, I keep repeating this. I want to make sure we walk out of here. Probably if there's one thing I would love everyone to agree with is that failures will happen. And it's not about making agents sort of like making failures never happen or preventing failures. It's about how we deal with these failures when they do happen. And you want them to be cheap. You want recovery from failures to be cheap. You want to be able to record and inform the platform which failures you're willing to tolerate and how to behave when these failures happen. Yep, we can keep going. It's okay. Yep, so the platform, in this case, Flight2 and Union, right? You would record, because of the platform awareness of all the external actions an agent took, all of this metadata is stored in the system, right? So you know which tools it called, which services it invoked, or what code it ran elsewhere, or custom code that ran elsewhere. And all of this information is available for you to train and build even better agents in the future. It's like metadata about metadata, really. Yeah, we can go next. All right, and then the last design principle is defended. And this is about scoping the execution, protecting your agent and your sessions from potentially spiraling out of control, or in this case, executing code that is untrusted. And it will happen, right? You will get to a point where the agent will look at 100 tools you gave it and says, none of these really do the job. I want to run this custom, travel flight lookup that I can't do with any of the tools you give me. I want to write code. And you want that. You want this sort of escape hatch in a lot of cases. But when that happens, you want to be able to run this in a secure environment that is, network isolated, that is isolated from the host, so it doesn't, affect the running processes, and be able to react to failures when you execute this code, right? So in this example, we ran some, generated code, and then we can wait for this to happen elsewhere. And shout out to Pydantic for the Monty project. It's if you haven't checked it out, please do. It's a low-level Python environment that is sandboxed, and we leveraged it here. And you want to react to failures when executing this code. That maybe in this example, right, in the naive example, you can just take the error, take the code, call back the LLM and say, well, I tried to run this thing, I got this error, iterate, right, give me better code, and then you try this a few times. Usually, the LLMs got a lot better at building code that runs and compiling it beforehand and so on. So eventually, you will get code that does the thing you want it to do. And then lastly, if that doesn't happen, you can bail out and ask the user, right? So you want a human-in-the-loop capability. You want to be able to say, hey, I tried to build this tool or tried to do this thing and I can't. Tell me what to do next. Or maybe it gave you a few options and you want to ask the user, which one would you prefer? You get that input and then proceed with the next steps, whatever that is, maybe actually booking the flight or whatever the agent is trying to do. All right, let's go next. Yeah, keep going. Okay, all right. So 3 design principles, we'll rehash them at the end. But when you put all of this together, you get a platform that is aware of your infrastructure, that can trace every action your agent took. So if you look on the left side here, every attempt the agent took or tried to do with the generated code is logged. You get the errors that it hit, and you see the new attempts. You see the code that eventually succeeded, and you can inspect, real-time logs. You can see the agent as it's running, what is it trying to do, and maybe what it's struggling with. So you can react and build maybe better agents and improve the experience for users. Take maybe a couple of minutes just really quickly as a real-world example. We recently published this case study. I would encourage you to check it out. There's this company called Dragonfly, and what they do is they're trying to solve the problem of choice, right? You want to add one more tool to your company, right? You want to add an HR tool or an issue tracker, or you want to add some piece to your company, but you don't know. There's a ton of those out there. You can go to Dragonfly and prompt them, tell them, hey, my stack looks like this. I have these tools for these things. How do I pick the issue tracker? Or I want to pick an issue tracker. And they have a catalog. They're constantly crawling and cataloging and indexing the software products out there. They have a catalog of more than 250,000 products. And they will give you, some recommendations, comparisons between products, and so on. And they came to us with this problem, and they wanted a way to build that catalog such that they can, query it at real time for their users. They wanted to build an agent. If you go next, this is the architecture that I give credits to my colleague Niels, has worked with them to architect this agent, not just for it to correctly deliver the job, the thing it's trying to do, but to do so reliably in production at that scale. And they created this 4-tiered system where at the top here, you have constantly running these 4 agents that are calling coordinators, and the coordinators are invoking researchers to research certain products, and have a bunch of tools, either querying a thing on a web search for that product, or checking the indexing, maybe the docs, and various ways of collecting data about a product. And they've even built some smartness in the coordinator layer that can look at multiple researchers and say, oh, you look like you're doing the same things. Let me stop one of you and let you do something else. And all of that is coordinated, all of that is traced, all of that is auditable for them to look at and learn from and build, again, improve their agents. And the impressive thing is that they took this from a sort of a prototype they were building on their laptop to do the thing they were trying to do, to a running thing in production in one session sitting with him. It's like a couple of hours, and this was running already on the system that can scale and can run in production and to research all the tools they have or the products they want to research. Okay, I'll leave you with this, and maybe I will a quick quiz, see who fell asleep. What was the first D? These sort of 3 Ds we talked about. Anybody remember the first one? Dynamic, yes, thank you. Second? Yes, great job. And third? Independent. Okay, awesome, thank you. We're happy to talk about them a lot more. Yeah, we have a booth out there. I love how cozy the place is. So you get to actually have one-to-one conversations with everyone here, which is amazing. So come check us out. We are hiring. We would love to work with you all on, how do we build agents. I would love to hear your hot takes on agents or building agents or your experiences. We have a bunch of us. We are Seattle local, and a bunch of our team is out there in the booth. We would love to come for you to come talk to us. Thank you.
All right. Not so fast, Haytham. Not so fast.
Okay.
We do have time for a couple of questions.
All right.
If anybody would like to ask a question. And if not, you can catch up with Haytham. Some conversation starters for him. He's into scuba diving. His whole family is doing fencing as a family sport right now. And he is also into woodworking. So if you have, looking for some conversation starters with Haytham after this session. Do we have any questions? Any questions?
We have one here, yeah.
Are you guys using any Erlang under the hood, or is this all Python?
That's a great question. So we use Python for our SDK. This is the user-facing, how you develop the agents. The system in the back is all built on Go and Rust services. So even the Python SDK has a Rust component that is running the coordination is super fast. But we're not using Erlang, no. Yeah, thank you.
Okay, we have one more question back here in the back.
So I work at a more traditional-based company that is a little bit more on the side of let the developers do their thing. So when they're dealing with infrastructure and calling that into the code, how do you deal with companies that are a little bit more on the side of not wanting to change that and get the developers wanting to start thinking about those things, essentially shifting left that piece of component there?
That's an awesome question. We do work, not to surprise anyone, but we do work with a lot of companies in the same boat, where you have a platform team that traditionally sort of was the sole owner of any piece that runs in the cloud, right? Like any service goes through them, any deployment goes through them, right? And we are seeing the same shift from their desire to empower the developers or the researchers, the MLEs, to build the tools themselves. And also from the researchers, because they see the iteration and the velocity to build once they get the control skyrocket, right? Because I think this is it depends on where you're seeing the friction, I would say. But if you want to sell this promise or the capability to your end developers, I would really show them how fast it is for them to iterate. They cannot get the same speed if there is another hop, which is, I need to get my code sort of packaged in a certain way and build a Helm chart around it and a deployment and so on by somebody else. Once they start experimenting this and being able to build a thing that runs locally, but get packaged and run remotely on a cluster and scale, get this cycle going really quickly, they will be all in. We have seen this happen in real time. Like I could see it in people's eyes once they experiment with the platform. Where are you seeing the friction, if I may ask? A follow-up question, I guess.
They have traditionally not thought about the infrastructure bits. And so I'm part of the infrastructure team. So having to educate the developers and then go, hey, these are the tools and things that could make your life easier, but it's just training a dog, essentially, and just trying to get them excited about the new potentials.
Yeah. Would love to work with you, I think, on showing them the benefits. Great. Yeah, thank you.
All right, one more time, let's show some love.
All right. Thank you, everyone. Appreciate it.